In this video, I'm going to go ahead and walk you through how we use inequalities in a real world scenario. We're going to go ahead and create some inequalities. We're going to go ahead and graph those inequalities. And then we're going to go ahead and look at the different constraints to mark points with solutions or non-solutions. So our scenario is a hairstylist charges $15 for an adult haircut and $9 for a child's haircut. She wants to earn at least $360 and cut a maximum of 30 haircuts. So we're going to go ahead and let X be the number of adults, and we're going to go ahead and let Y be the number of child haircuts. So basically there are two constraints here. The first constraint is that she wants to earn at least $360, but her second constraint is going to be that she also wants to cut, or she can't cut more than 30 haircuts. So there's a maximum of 30 haircuts that she can do in a week. So we want to go ahead and create two inequalities. Part A says the first inequality that we want to go ahead and create models the number of haircuts. So basically, some number of adult haircuts, which represents X, plus some number of Y haircuts that represents children, should be less than or equal to 30. So she can do 30, but she can't do 31. But she can do 15, 16, 17. That all works within her constraints. So that is going to be our first inequality. Our second inequality has to do with our second condition, the $360. So she wants to make at least 360, which means that she wants to make at minimum 360. She doesn't want to make anything less. She doesn't want to make $300, but she's happy with making $400. So that means that an adult haircut that costs $15, so 15X, plus a child's haircut that costs $9, so 9Y, must be greater than or equal to $360. That's going to be our second inequality. Now that we have the equations, the way in which that we're going to go ahead and graph these looks like this. So in my first inequality, you're going to go ahead and copy this down twice. If we look here at this equation, what we're going to do is we're going to make one of these X's or Y's be 0. So if I let this be 0, what that means is that it's not there. We can kind of just cross it out and not think of it. So what that means is that we have Y, which is less than or equal to 30. So we're going to pay attention to this equal sign. Y is equal to 30, which means that we can go ahead and put a point at 30 on the Y-axis. I'm going to do something similar, but now instead of making X 0, I'm going to go ahead and make Y 0. So if I make Y 0, then I can go ahead and eliminate that term altogether. And again, we have X is less than or equal to 30, but we're going to pay attention to that equal sign. So when Y is 0, again, when Y is 0, we know that X is going to be 30. What we have just graphed, or what we've just plotted, are two intercepts, the X-intercept and the Y-intercept. And I can draw a line between them. Now, this is a solid line because there's an equal sign. And if she can only cut 30 haircuts, that means that the maximum is 30. So everything that she can do that is feasible is going to live below this region. Everything that she can cut in a week is going to live below this region. Let's go ahead and graph our second inequality. I'm going to use the same method. You're going to go ahead and start by copying this down twice. And just like I did before, I'm going to go ahead and make one of these 0. One of these meaning either X or Y. So if I make X 0 here, that's going to be 15 times 0. That means that term is gone. So what you're left with is 9Y is greater than or equal to 360. So to get Y by itself means that I have to divide by 9. Y is going to be greater than or equal to 360 divided by 9, which is going to be 40. Which means, again, we're going to pay attention to that equal sign. So Y is equal to 40. When X is 0, when X is 0, Y is equal to 40. I'm going to go ahead and put a point there. When X is 0, Y is 40. Now go ahead and look at this inequality. We're going to do the same thing. We're going to say, well, what if Y was 0? That means that term's not there because 9 times 0 is nothing. So now I have 15X is greater than or equal to 360. So I'm going to go ahead and get x by itself by dividing by 15. And so I get x is greater than or equal to 15 goes into 360. Gosh, how many times? Goes in, is it 24 times? Let's check. 24 times 15. That's going to be 5 times 4, which is 20. Carry the 2. Then 5 times 2 is 10, plus the 2 that I carried is 12. You don't need to bother with this. You can just go ahead and plug this into your calculator, but I just wanted to double check. I don't have one nearby. Yep, so 15 goes into 360 24 times. So that means when y is 0, x was 24. So I come over here and I put a point at 24. I'm going to go ahead and draw a line between those two intercepts. Now she wants to make at least $360, which means that she's hoping to make more money. So more money is going to exist above this line. So you can see that there is a very small region here. There's a very small region where this is going to be the number of haircuts that gets her both of those conditions. She's making more than $360, but she's cutting fewer than 30 haircuts. So in part D, E, and F, we're trying to describe solutions and non-solutions. So in D says, hey, list one combination of adult and child haircut that would work. So we want something that would work, which is going to be in the region that we just graphed here. So you're going to choose any point in that region. For example, I can choose this point here. So that means that that's going to be 25 and 2. 25 is the x coordinate, meaning that's the adult haircuts. 2 is the y coordinate, which means that's the child haircuts. So 25 adults and 2 children. Oh, I'm supposed to mark this with a star. Mark this with a star. Boom. Mark that with a star. Let's go ahead and look at E. E says list one combination of adult and child haircuts that could meet the number of haircuts but does not, they should say does not earn at least $360. So the $360 is in that pink region. So she could very well cut 5 adult haircuts and 5 children haircuts, which technically is less than 30, so it meets this model here, but she's not going to earn more than $360, which is in this region here. So we're asked to go ahead and put a square. So we're going to go ahead and put a square here. Another way that you could put a square is here as well. 10 adults and 10 children haircuts is less than 30 haircuts, but will not earn her more than $360. So I mean, there's an infinite number of answers here. I'm just going to go ahead and go with my first one, which is 5 adults and 5 children. Or child haircuts. There we go. Okay, in F, we are now looking for a combination of adult and child haircuts that does not meet the number of haircuts but does earn her at least $360. So looking at my graph here, that's going to be anything in this region here. For example, if I can cut 25 adults, because this number is at 25, the x-coordinate's at 25 and the y-coordinate is 15. So what we're saying here is that she can cut 25 adults haircuts and 15 children haircuts, and yes, certainly earn more than $360 there, but she doesn't have enough time in her week to cut 40 haircuts. So it meets this model, but it does not meet this model. And the directions say that we want to go ahead and mark this point with a triangle. So we're going to go ahead and put a triangle here. And again, this is not the only point. I mean, she could be cutting, like we could put a triangle here. Technically, if I were to extend this shaded region in this zone here, right? This goes all the way over. I just kind of stopped because I was being lazy. But we could put triangles anywhere in this pink zone. That will definitely earn her over $360, but she's cutting too much hair. She can't cut, for example, in this problem or this point here, she can't cut 35 adults and 35 children haircuts. That would be 70 haircuts a week, and she only wants to do a maximum of 30. So I'm going to go ahead and put my original point, 25 adults, and what was the 25 and 15? 15 child haircuts. There you go.